Hey class, we're going to take a look at 4.3 day 2. So 4.3 we talked about, we started talking about rational functions, and we talked about what are called vertical asymptotes. I mentioned horizontal asymptotes, and that's what the focus of today is going to be. So you need to know how to find, so eventually the next class we're going to graph these things. Okay, we're going to graph rational functions. So you need to know how to graph, you need to know how to find the vertical asymptotes. Today we're going to talk about the horizontal asymptotes or something that's called an oblique asymptote. And these are going to be like the first two things that we find before we try to find some points to graph these. Okay, so a horizontal asymptote merely describes what is happening as your x values are going towards negative infinity or towards positive infinity. Okay, so for really big values of x, your function starts to get closer and closer to some value. So the example I did, we were getting closer and closer to 2. We weren't quite getting there. We were getting to 2.01 and 2.00001, but we were never going to quite hit the 2. Okay, and that's an example of a horizontal asymptote. It's just something you approach as your x's get really big or really small. It does not tell you what happens here in the middle. Okay, so we may be able to equal this value somewhere. We may cross this line at some point, like some here in the middle of the graph, but not towards negative or positive infinity. Now, if you take a horizontal asymptote, which would be like y equals 2 or y equals whatever, y equals 1, okay, if you take it and you add slope to it, so you put it at an angle, then it's called an oblique asymptote. Okay, it's very similar. It's the same idea. As your x's get really big, your graph just kind of takes off at this angle, and the values are getting closer and closer to this line right here. Okay, and then same thing as you head towards negative infinity, your graph just kind of starts to follow these values that mimic this line. So again, it's just an imaginary line that our graph just seems to get closer and closer to as our x values get bigger and bigger. Now, for an oblique asymptote, it's going to be a line that has slope to it. So that's what our equation is going to look like. So like y equals mx plus b. That's your standard slope-intercept form from Algebra 1. Whereas a horizontal asymptote is just y equals whatever number that is. Okay, it's a horizontal line. So down here on the bottom, I've got an example of a graph. And then I just asked some questions about it. So like state the domain and the range. Well, your domain, that's your x values. So the domain, well, if we look at this graph goes from negative infinity, and then it comes in, and then it curves, and it starts going up. Right where this, if you see, there's a dotted line right here. Well, this is the y-axis, which would be x equals 0. So this graph, x equals 0, must be a vertical asymptote that our graph is getting close to, but it doesn't want to touch. Okay, so our domain would be x cannot equal 0. Your range, that's your y values. Okay, so what's this graph doing in the y direction? This is going towards negative infinity, and then it comes up, and then it gets to like negative 2, and then it turns and goes back down. So negative infinity up to negative 2. Now, we put a parenthesis on negative infinity. You always put a parenthesis on infinities. But we do equal negative 2, so we're going to put a bracket right there. And then there's this big gap. And then our graph starts at 2 and goes to infinity. So we're going to union that with the numbers from 2 to infinity. Okay, and that's our domain and range of that graph. List the x and y intercepts. Well, we never cross the x-axis. We are never going to cross the y-axis because that's a vertical asymptote, so there's none. Okay, so that could be an answer. The answer could be none. List the vertical asymptotes. We already did. We said that x equals 0 is a vertical asymptote. And then it says list the horizontal asymptotes, and it says list the oblique asymptotes. Well, you can only have one or the other. You can have as many vertical asymptotes as you want. I could make a function that has 5 different vertical asymptotes, but you're always only going to have one horizontal or one oblique. You can't even have both of them. So in this case, if you look, there's this dotted line that's going at an angle. So that's an oblique asymptote. So this is what we have. We've got an oblique asymptote, and they want us to write the equation for that. So again, y equals mx plus b is the form we're going to use. So what do we got going here? Well, our y-intercept is 0, so that's going to be a 0. And then our slope, if you pick a couple points that are on the dotted line, you go down 1 over 1. So that would be a slope of -1. So y equals -1x plus, and then 0. Now, you don't have to put the -1x. You could just put -x. You don't have to put the plus 0. Okay, you could just have y equals -x. That'd be a perfectly good example. But for your notes, I wanted to be clear as to what those numbers were. Okay? All right, so our main goal today is going to be when you're looking at a rational function, how do you find the horizontal or the oblique asymptote? Because again, that's one of the first things we're going to find when we graph these. So here is an example. This is a generic rational function. You got some crazy polynomial on top, you got some crazy polynomial on bottom, but don't worry about how big or crazy this looks. For horizontal and oblique asymptotes, all we need to do is we just need to look at the very first term. Okay, so no matter how big the top and the bottom are, all we're going to do is we're going to look at the very first term. And then more importantly, we're just going to look at these exponents right here. So we've got x to the nth power and we got x to the mth power. Okay, and we're just going to compare those two. So we've got 4 rules right here, and then I'm going to give you some examples showing the rules. But here's what the rules say. It says if n is less than m, so if this exponent is smaller than this exponent, then, let me kind of skip through here, then y equals 0, so the x-axis is going to be a horizontal asymptote. Okay, so if you have some function, f of x equals, and let's say it's x squared plus whatever, doesn't matter what's after the x squared, and you have an x to the 5th plus whatever. Okay, doesn't matter. If this number is smaller than this number, then the x-axis, y equals 0, is a horizontal asymptote. So there's no math to do. You just look at it and tell. If the n and the m are equal to each other, okay, so if these two numbers are the same, pretend that they cancel each other out. Okay, so if this is an x to the 4th and this is an x to the 4th, pretend they cancel each other out. And then these two numbers right here, the a over the b, that number, that's where your horizontal asymptote is going to be. So what you'll get is something like this. You'll get f of x equals, and then you'll have 3x to the 4th plus whatever. And then down here you'll just have plain x to the 4th plus whatever. Okay, you'll have something like that. These two, imagine they cancel out, and they just leave you with 3 over 1. That is where your horizontal asymptote is. Okay, so again, that's an easy one, but you got to remember these rules. The rules aren't hard, you're just going to have to remember them. Okay, now, I'm going to jump down. Number 3 and 4 have to do with what happens if n is bigger than m. Okay, if n is bigger than m by exactly 1. So if this is an x to the 4th and this is an x cubed, or if this is an x cubed and this is an x squared, so it's got to be bigger by exactly 1, then that's when you're going to have an oblique asymptote. And what we're going to do is we're going to have to do division. We're going to have to literally take the top number and divide it by the bottom, which we can do because the top's bigger than the bottom. That's the whole point of this. We're going to take the top, divide it by the bottom, and then our answer is going to be something that looks like this. It'll be something x to the 1st power plus some number, and that's going to be our line. Okay, so our book uses A and B instead of like M and B. That is A, B, C, D. They're just using letters in order instead of the normal slope intercept that you're used to. But I'll show you an example of where this happens. Okay, if the n is bigger than m by more than 1, so like by 2 or more, then you just don't have any asymptotes. The graph doesn't approach some line and kind of goes off into space. Okay, so on the bottom, I've got 4 examples here. So look at the first one. The first one says 2x squared plus 7x minus 1, and then x squared plus 2. So all you're looking at are these two numbers right there. And the fact that x squared over x squared, those are the same, okay, that's rule 2, which says you pretend the x's cancel out, you just look at the numbers, 2, think of this as a 1, that's a 1. So 2 over 1, so y equals 2. We're done. That's where our horizontal asymptote would be. And when we graph these, we'll go up 2, we'll draw a dotted line, and then we'll know something about our graph. Okay, look at C. Look at this huge rational function I created. But if you look at the first terms, you'll see this is x to the 5th, this is x to the 6th. That's rule 1. It says if this is smaller than that, then y equals 0 is a horizontal asymptote. And you're done. That's it. That's the only rule. Okay? That's the only thing you got to worry about. Now, I know I went sideways. This is A and this is C. And now I'm jumping down to B. Now, this is rule 3. This is one bigger than this. So we are going to divide this by this to figure out what our oblique asymptote is. So for this, we're going to use long division. So I'm going to show you how to do an example of long division. We're going to take the top, x squared plus 4x plus 1, and we're going to divide it by, so just like you did in like elementary school, we're going to divide something by something else. And then here's what you do. All you do is you look at the first terms, the x and the x squared, and you think, I need to multiply something by x to turn it into this. Well, if you multiply x times itself, x, you'll get x squared. So that's what we're going to do. That's what goes on the top. And then you do that. You multiply x times x, x squared, x times -2, so you're going to distribute. You're going to multiply this x times everything. And then what do you do in long division? You subtract this row from that row. You subtract everything. Well, the x squared minus x squared cancels. And then 4x minus -2x is 6x. And then what do you do in long division? You bring down the next number, plus 1, and then you do it all again. You look at the x, and you look at the 6x, and you say, if I multiply this by a 6, I'm going to get 6x. So 6 times x, 6x. 6 times -2 is -12. And then we subtract that row, which would get us 0 here. And then 1 minus -12 is 13. That's the remainder. Now, this isn't important to us. This is our answer. Y equals x plus 6 is an oblique asymptote that our graph is going to follow. So go up to 6. 1, 2, 3, 4, 5, 6. Draw a line that has a slope up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1. Okay? And that would be our oblique asymptote. Okay? For D, same thing. I've got x to the 4th, x to the x cubed. So this is one bigger than this. So for this one, 3x to the 4th. Now, you can't have any gaps. So notice how I'm missing an x cubed. I've got to account for that. So I'm going to have plus 0x cubed, then minus x squared, and then plus 0x, and then plus 0. I'm going to account for all the missing gaps in this. And I'm going to divide this by, this one has a missing gap as well at 0. X cubed minus x squared plus 0x plus 1. Now, this looks like it's going to be a lot of work, but it's really not. There's just two things you have to do. You've got to figure out, what do I multiply x cubed by to get 3x to the 4th? Well, I need a 3 and I need another x. So that's the first part. My answer is actually halfway done. 3x times x cubed is 3x to the 4th. 3x times minus x squared is going to be minus 3x cubed. So see how everything lines up because I added that 0x cubed. 3x times 0x is going to be 0x squared. 3x times 1 is going to be 3x. And then you subtract everything. These cancel. 0x cubed minus negative is the same as plus, so that's 3x cubed. Minus x squared minus 0 is going to be minus x squared. And then 0x minus 3x is minus 3x. Now, again, what do I multiply x cubed to get 3x cubed? Well, a 3. That's it. Stop. You're done. As soon as you have, that's your slope, that's your y-intercept. You're done. So as bad as that division looked, it looked like it was going to take us forever, this is your answer. Okay? So today, take a look at your homework. We're focusing on horizontal and oblique asymptotes. Keep those rules handy so that you know what to do and what you're looking for to figure out where the horizontal or oblique asymptote is. All right, guys.